This is Geometry, Semester 2. It's a area and perimeter review unit. It's unit number 9. And then it's the first lesson of that unit called Squares, Rectangles, Triangles, Circles, etc. Practice, right? It's on creatormath.com. Under the Geometry tab, you might have to type into Google creatormath.weebly.com to find it. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So just before I start some problems here, if I could pull up that table of contents, that might help you orient yourself to what we're talking about here. So creatormath.weebly.com. The home page looks like this. Once you're there, you're going to, this is a geometry lesson, so all the notes and lesson videos are under the tab, Geometry. Pass by vocabulary, this is vocabulary up front, find the table of contents. So this is Semester 2, table of contents. This should be copied into your pages 2 through 6 of your comp book already. We're going to go down and find the right unit here, or correct unit. Conics, angles, area, Pythagorean. There it is. I passed by it. Area and perimeter. This is review. All right. There's another unit in there called area and perimeter. This is the review unit, and there are only 2 lessons to this because it's review. You'll find the notes right here under this tab. Problems, and then the solutions video. The video solutions will be put up right here too. So these links will all be active by the time you see this and or need it. Here are the pages it goes in your comp book, and here's the right title to follow. With that said, let's look at some of the practice problems. So for the following shapes, perimeter and area formulas are shown. Remember, the units of perimeter are a distance, length, units to the power 1, and units of area is units to the power 2. We'll talk about that as we go through the problems. Here's the first one. Given a square with side length 5, so this side length is 5 long here, and we can call it units. They give us they give us centimeters. Can't talk, I'm sorry about that. What is the area and what is the perimeter? So area is this inside of the boundaries of the shape. And perimeter is the distance around the shape starting here, going this way, this way, this way, and this way. It doesn't matter where you start as long as you finish at the same point. So let's talk about area. They give us area as s squared, and we have 5 centimeters. So if area equals s squared, which is a side length squared, it's like base times height or length times width, which a lot of students already know. So we have area equals 5 centimeters squared. We're going to square both the number. The number squares 5 times 5 is 25. And centimeter squares, it's centimeter times centimeter or centimeter squared, which is good because we're dealing with an area. So looks like we already know it's this answer, 25 centimeters square. Let's check perimeter and see if that works out. If each one of these sides is 5 long, we start here and go 5, 10, 15, 20. Done. Check, 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 check. This is only a centimeter because it's a length. This is a centimeter squared because it's an area. Given a rectangle with side lengths 5 and 10, so let's call the shorter side 5 and the longer side 10. Area is length times width, so area equals LW, area equals, and do they give us units? They say 5 feet and 10 feet. So let's say 5 feet times 10 feet. We're going to multiply the numbers times each other. Area equals 5 times 10 is 50. We're also going to multiply the units. So feet times feet is feet squared, and that's how we get feet squared for area. So 50 feet squared looks like this answer. Let's check perimeter. This one's 10, this one's 5. Let's start here. 5, 15, 20, and 30. So 30, it's feet because it's a distance. 50 feet squared we got right here. Given the following graph, what is the area and perimeter? So this one is on a Cartesian coordinate system. Remember that they are points plotted, which is x comma y. It's always this format. I remember once in high school I got confused. I'm like, is it always x, y? Always. The horizontal axis is always x. The vertical axis is always y. Always, always, always. That's the whole point of the system, is to remain consistent. So if this is 0, 0, the origin, and then we come out to this point, we went out 5 on the x and 0 on the y. So this is 5. Then even if we're here, if we go up to 5, see how the y goes from 0 to 5? This is 5. And it looks like this is going from 0, 5 to 5, 5. The x value is the one we're looking at. It's going from 0 to 5, so this is 5 long. We're looking at the y value here. It's going from 0 to 5, so this is 5. So it's just a square with side length 5, which we actually already calculated. So let's go ahead and say area equals s squared, which equals 5. Do they give us a dimension? No, so let's call it units, okay? That's just generic. It could be feet, centimeters, meters. Let's call it units. And we're going to square it. So area equals 5 times 5 is 25, and units times units is units squared. I guess I should spell it out. It's hard to see what my u is, units squared. So let's find 25 units squared. That's this answer here. Let's check perimeter. 5, 10, 15, 20. Check, and it's in units to the 1 power, which is good because it is a length or distance. Given the following graph, what is the perimeter? What is the area and perimeter? Let's modify that because it looks like we've got area and perimeter down here. So how long are each of these? We're going from 0 to 9. This is 9. We're going from 0 to 5. This is 5. We're going from 0 to 9. This is 9. And so this has got to be 5. So we're dealing with length times width. Area equals LW. Area equals, and we can put units on it since none are specified, 9 units times 5 units. 9 times 5 is 45. And units times units is units to the power 2. And that's good because it's an area. So 45 units squared, this is our correct answer. Let's check perimeter. 9. 9 plus 5 is 14. 14 plus 9 is 23. 23 plus 5 is 28. So it looks like I got 28, and it's only units to the 1 power because that is a distance. Given a triangle with base 8 meters. So here's a base, 8 meters. Check. And 2 side lengths, 6 and 7. Let's make this 6 meters and this 7 meters. And perpendicular height of 4 meters. So this perpendicular height here equals 4 meters. Perpendicular means it's at a 90-degree angle to the base. What is the area and perimeter? So area of a triangle is 1/2 base times height. Area equals 1/2 base times height. And just so you know, it is perpendicular height right here. That's very important. So I know they're giving us the length of these sides, but those are at an angle. They cannot be used for height. We must use the altitude or perpendicular height. So 1/2 base, which is 8 meters, times perpendicular height, which is 4 meters. 8 times 4 is 32, divided by 2 is 16. 4 times 8 is 32. 4 times 8 is 32. Divided by 2 is 16. I like 16 meters squared. And let's check perimeter. This would be 8 and 7 is 15, would be 21. So this one works out in meters, and the units work out, but I'd like this to be 16 right here. Just one more time. It says base of 8. It says perpendicular height of 4. 4 times 8 is 32, divided by 2 is 16, as far as I know. Unless I'm calculating it wrong or missing something. All right, I'll work on that before you get the actual problem. So we'll use this one and we'll fix it, okay? Given a circle with a diameter of 8 units, what is the area and perimeter? So diameter is the from side to side of the circle, or actually from circle to circle through the center. It's saying diameter is 8 units of this circle. We have the area of a circle equals pi r squared, but we don't have an r, we have a d. So here's the r here. Radius is 1/2 the length of diameter. So if we have a diameter, we have to divide it by 2. So let's modify this and say pi d over 2 and then square it. So that'll take the diameter, divide it by 2, which will take us back to what is radius. So area equals 8 units, or pi, 8 units, divided by 2, and squared. Area equals 8 divided by 2 is 4. 4 squared is 16, so I like 16 pi right here for area. Units is being squared, so it's units squared. And that's good because we need to have an area squared. They also ask for perimeter. Perimeter is 2 pi r. So P equals 2 pi r. Again, we don't have an r, we have a d. So P equals 2 pi d over 2. Well, the 2's cancel, and we're left with d pi, or pi d. So perimeter equals the diameter is 8 pi. So I'm looking for, and this would be to the unit 1 power, or just unit, we would say. So looks like 16 pi units squared, 8 pi unit to 1. I like this right here. All this matches up with what we just calculated. Yeah, just a note. It says area and perimeter. When it comes to circles, we call this circumference. Right? We use a different word. It means the distance around the shape. So I get what they mean when they say perimeter. You told me to find the perimeter of a circle. I can do it. But the technical term is circumference, and look, they're using it correctly here. They is me, just so you know. I say they like I didn't write this, but I did. It was a long time ago, so I've missed a lot of things. Given the following circle, if the diameter is 10 units, what is the area and circumference? Same thing. They're giving us diameter, and they're giving us 10 units. So let's roll through the same calculation. Area equals pi r squared. Area equals pi d over 2 squared. Area equals pi 10 units over 2 squared. Area equals 10 over 2 is 5 squared is 25. Pi units squared is units squared. So I'm liking this one, 25 pi. It's really hard to see right there, but there's a pi right there. And let's see perimeter. Perimeter is our circumference in this case. C equals 2 pi r. C equals 2 pi d over 2. Cancel, cancel. C equals d times pi. D is 10 in this case, so 10 pi units. And it is to the 1 power, so there's again a pi here that's fading out. Not printing very well right there. Circumference, diameter. You know, sometimes it can help you memorize a word like R, you could say rat, and diameter you could say dinosaur. And that way you could remember the bigger animal is the larger distance, right? And the rat is a smaller distance, so that would be radius. Students still confuse that every once in a while. And I was going to say something else about circles, but I forget. Let's move on. So given the following circle, if the radius is 6, so now they're giving us a radius here of 6 units. What's the area and perimeter? Area equals pi r squared. Area equals pi 6 units squared. Area equals 36. So 6 times 6 is 36. There's a pi. I'm going to keep that in there. And then units times units is units squared. So 36 pi, there's a pi right there. It's hard to see. Pi units squared. Let's do circumference equals 2 pi r. Circumference equals 2 pi, and the r we're told is 6 units. 2 times 6 is 12. So 12 pi units, and this units is to the 1 power, which is good here. This is a pi right there, hard to see. Remember, my answer choices are all A. Yours are going to be randomized. Why are the units for perimeter raised to the power 1? Because it's one-dimensional. So here's a distance, you guys. This. How many dimensions is that? It's one dimension. Just one. And if it were, just pretend it's an axis, right? It's an x-axis. It's just one dimension, so it's going to have units to the power 1. All right, let's take it up a notch. Why are the units for area raised to the power 2? Why? If this was one dimension, How many dimensions now? We have a dimension this way, horizontal, and we have a dimension this way. So two-dimensional. Two dimensions must be raised to the power 2. And you've seen that. You've seen our units. The units of this dimension multiplies by the units of that. We get units squared, or square units. And just one more step. It doesn't say it here, but what if you have 3 dimensions? 3 dimensions will be raised to the power 3. Why? 1, 2, and 3. 3 dimensions will have units raised to the power 3. All right, so what are the common 3 dimensions? Length, width, and height, and horizontal, vertical, and depth. This is horizontal, vertical, and depth. And if you had, another shape here, let's say it's a rectangular prism, a lot of students will think, as you've rightly learned, length, width, and height. It doesn't matter if you call them whatever you want. Just stick to the 3 dimensions, and you'll be fine. Why do we leave the pi in our answers instead of substituting in 3.14? So back in grade school, or maybe even middle school, not grade school, but maybe middle school, probably when you're learning about pi, they tell you to substitute 3.14 in. Well, the truth is pi is an irrational number. 3.14159265, on and on it goes forever. So if you do 3.14, you cut off all those extra digits. It's actually less accurate to say 3.14 than it is to say pi. So back up in these answers, you're like, why did we leave pi in the answer? Because now you have a perfectly accurate answer. So shockingly, when you get up into higher level math, you do less, plugging it into your calculator, and just leaving it with the pi in there is actually a more accurate answer. So because the symbol pi represents all infinite digits of pi and is therefore more accurate than using 3.14, I'm going to fix that for you guys, 3.14, fix that for you guys, which is only an approximation of pi. 3.14 is only an approximation, so we don't use it because it's less accurate. All right, so make sure you're matching up the correct title here. This is Geometry Semester 2. This is Unit number 9, Area and Perimeter Review, and this is lesson number 1 of that unit, called Squares, Rectangles, Triangles, Circles, etc. Practice, and it's on creatormath.com or creatormath.weebly.com under the Geometry tab. Hope this helps.